You are welcome to section 6. In section 5, we did some calculations on Graham's law of diffusion of gases, and here will be the final section for this course. Now let's look at the question that we have in this section. 60 centimeter cube of a gas K having an empirical formula of CH3 diffused through a porous partition in 23 seconds. Then hydrogen of the same volume diffused in 5.9 seconds under the same conditions. Question A. What is the molecular mass of gas K? Question B. Find the molecular formula of the gas. Question C. Suggest a name for the gas. And then question D. Draw the structure for the gas. Now you will quickly notice so many things that we have to do here. The first thing you have to do is to understand the question. Same volume, please note that. And there's a formula that we derived together on how to solve question when the volumes are the same, when the two gases have the same volume. And if you go back to the derivation of the formulas, you quickly recall that we have a formula like time of K over time of hydrogen gas is equals to the relative molecular mass of K all over relative molecular mass of what? Of hydrogen. And this is the formula we derived together because they have the same volume. Now let's bring out what we are given. We are given the time for gas K to diffuse, and that is Tk. Tk is 23 seconds. Very good. Now you notice that also we have time for hydrogen gas to diffuse, and that is also 5.9 seconds. We can quickly calculate the relative molecular mass of hydrogen. Good. And that is what? 1 times 2. Because the relative atomic mass is 1, therefore times 2, that gives us 2. So, having known all this, we can quickly input the formulas into, you can quickly input the values into the formula. So, let's move on from there. We're going to be having 23 seconds, everything over the time to diffuse is 5.9 seconds, equals the relative molecular mass of gas K over the relative molecular mass of hydrogen. We got 2. If I cross multiply very well, I will be having relative molecular mass of K will now be equals to 23 times root 2. Very good. Everything over 5.9. Very good. Now, for us to calculate the relative molecular mass of K, so if you squared both sides, you are going to be having the square, we cancel the square root here. Good. We're going to be having this into what? 23 squared times root 2 squared will give us 2. Then everything over what? Over 5.9 squared will give us 34.81. If you do this very well with your calculator, you'll be getting 30.4. That means the relative molecular mass of gas K is now what? 30.4. So we have gotten that. So the next thing the question says, question B, we can approximate that as 30. So question A says we calculate the relative molecular mass of gas K. So the relative molecular mass of gas K is now approximately equals to 30. Remember, no units. Now question B says Calculate the molecular formula. In our previous courses, you can go and buy the courses. We did courses on molecular formula and empirical formula. You can go and buy the courses as well. And you have to know that empirical formula, we are given that in the question. Empirical formula times n will give us relative molecular mass, right? And from the question, we are given the empirical formula as CH3. Good. And that gives us what? N. Very good. Then equals to 30 that we found here. Remember, the relative atomic mass of carbon is 12. Hydrogen is 1 times 3. We get 3. Then times N equals to 30. So we have this as 15N equals to 30. Therefore, N becomes what? 30 over 15. And N equals to 2. Now, having known N, we can actually get the question B. And it says what? We should calculate the molecular formula. So the molecular formula is now going to be what? Remember, we got CH3N. And N is now 2. And that becomes what? C2H6. And that is the molecular formula. And question C says we should suggest a name for it. This is ethane. Ethane is an organic compound, is a hydrocarbon. And the general formula for ethane is CN H2N plus 2. So we have gotten that. Now the last question says we should calculate what? Question D. We should calculate, or we should draw the structure of C2H6. And how do we draw the structure of C2H6? There's a course that we have as well on organic compound. We have 2 carbon. And remember, 4 shells must surround this. So we have this all together. We have this. We have this. So this is a typical structure of ethane. It can also be written as CH3 is, then we have CH3. So this is the structure of the gas obtained from our calculation. Thank you for buying this course, and I want to believe that you have understood everything on this. You can as well go to the advanced level of this course. See you in advanced level.